Okay, well, I'll like talk into it very directly. But we focus on the data piece of the stack. So we allow users to kind of aggregate and pool their data into different data DAOs that are then used to train AI models. One of our guiding use cases is how do you create a model where 100 million users collectively contribute their data. So you have like 500 trillion tokens and actually beat the performance of like leading centralized companies and the models that they train. So yeah, we really focus on that data part of the stack, specifically private user-owned data and allowing people to train AI models on it.
Hi everyone, my name is Jeremy. I'm leading business operations at a company called Hyperbolic. So at Hyperbolic, we are focalizing on building decentralized AI infrastructure. And for this, we're tackling 3 core goals. So goal number 1 being the GPU orchestration layer. Goal number 2 being the verification layer and eventually the privacy layer. So on the orchestration, like GPU orchestration, we're building 2 core products. The first one being a GPU marketplace, connecting suppliers of compute onto a network in order to offer it, to the people who need it the most, AI researchers, developers, startups, and so on and so forth. And then on top of this, we're also focalizing a lot on building an AI services layer. For now, we are offering inference. So we're hosting open source models that we're optimizing. You can think about all of the big ones, the Llama 3 family, but also the image generation with Flux and a bunch of others like Stable Diffusion, as well as VLMs and audio generation. So yeah, that's basically what we're focalizing on.
Hey everyone, my name is Miguel. I'm co-founder and chief scientist of Nillion. Nillion is building the Blind Computer, which is a decentralized infrastructure that enables developers to run computations in a privacy-preserving way and also store information in a privacy-preserving way, all of it in a decentralized form, and while also interacting and interconnecting to standard blockchain technology. And we are spending a lot of time and resources on AI. We think it's one of the main use cases of interest for privacy-enhancing technologies. We're not betting on a single privacy-enhancing technology, but on the combination of them to actually provide developers with a wide range of possibilities. We have a product on that front that is called the AI VM that, front-facing the user, it looks like PyTorch, but under the hood is running all these privacy-enhancing technologies, and it's also linked to recent development and research we've done in collaboration with other companies, like, for example, Meta. And also a closely related product is an encrypted database that enables developers to store a lot of information that is obviously very relevant for AI.
Great. I'm Harry, co-founder of Gensyn. My background was actually in machine learning, similar to you, Evan, before joining the crypto industry. Gensyn is a machine intelligence network, so we want to allow machines to access all the resources required to bootstrap their own intelligence and create value for themselves or for humans. Concretely, that looks like allowing machine learning operations to be executed maximally across every single device in the world. And there's 2 kind of core, contributions we make to that effort. The first is verification, so enabling the trust problem to be solved where there's devices that aren't necessarily trustworthy. And then secondly, it's the optimal sharding of models across all those devices. So how do you maximally saturate everything given an arbitrary model?
Thank you. Yeah, so I think everyone's kind of seems like they're working on different slices of the stack to try to improve it. Maybe we can go through just where do you see the current problems and challenges in the area you're working on of this training and inference space, and how are you working to kind of address those problems? And I'm also curious about when do you expect that to start having impact and actually start potentially changing how some of these pieces of training and inference operates?
Yeah, I think from a data perspective, one of the big issues that AI researchers face today is this idea of a data wall, where we're actually running out of data to train AI models on, which is kind of crazy if you think about the fact that an AI model has consumed almost the whole public internet. No human has ever done that. That's a huge amount of information, but it's still not enough. If you want to put numbers on it, it's around 15 trillion words. That's sort of the size of these training data sets. And if we want to make AI better, we need to actually like scale that data set. So the way that we're solving it at Vana is having users kind of break through a walled garden by exporting their data from each platform and then aggregating it. In terms of kind of timelines, like I think that today what we primarily see the data used for is more model fine tuning, right? So you're not yet exceeding the ability of any single centralized company. There is a project with Flower AI, which is a federated training company, where they'll be doing full model pre-training across all the different data DAOs. And that's a really big milestone because it's not just taking an existing AI model and making it a little bit better. It's actually the start of like a truly user-owned foundation model that can compete with some of the large players.
Yeah. So on Hyperbolic side, everything gets to start first around compute. So obviously inference is the second layer, but actually we focalize on compute because this is a problem that stemmed from the CTO before actually, focalizing on, trying to build Hyperbolic. Our CTO was struggling very much to actually get access to compute, because of the shortage, because of the fact that the demand is far surpassing the supply, and even if he actually could get his hands into it, the price was crazy because of the margins that are being applied by centralized solutions and centralized actors like GCP and Azure and all of the AWS and all of the big ones that we know. And so that is actually the fundamental aspect of building decentralized AI compute, because we can, in a very easy way, as we get to build a robust and scalable backend architecture, make it extremely easable for any suppliers of compute that have idle capacity to actually share on a specific network like Hyperbolic, and actually make it accessible in terms of pricing. First, in terms of availability, but second, in terms of pricing for the people who need the most. Like AI developers all around the world are struggling with that. Researchers are as well, and obviously AI startups, especially when they're early stage and they want to have they want to build the MVP in order to get to fundraise. So on the compute side, that's the first aspect, and then same thing. If they basically get to need a lot of requests on the API side of things for inference, you obviously need machines, and so this is something that we can provide through decentralized networks.
So on the privacy front, talking about hardware, you're working with TEs. There's a lot of improvement that have been made in the last years. For example, you're able now to connect within the enclave the CPU with multiple GPUs, and also to extend attestations to the multiple GPUs. So that enables you to essentially run from 7 billion llama to 70 billion llama, even beyond that, through the use of multiple GPUs. And the performance penalties compared to plain text operations would be 10%, around 10%, maybe even below, if you're able to fit the whole model inside. The challenges with hardware-based solutions are more on the security side, because you have to trust the vendor. There's been vulnerabilities found in the past. There's side channel attacks and things like that. On the software front, where you are no longer trusting any hardware provider, but you're running privacy-enhancing technologies like fully homomorphic encryption or MPC, the challenge is definitely on performance. So we're seeing inferences of inference times of models that are up to 1 billion parameters in the order of a few seconds, which is obviously way slower than you would find in plain text. So people building on us, what we're seeing is that they go for smaller models. They, for example, BERT, they train them on domain-specific things, like, for example, health or accounting or your financial advisor. And then you find way faster, much faster runtimes. And also, if you're able or willing to put the weights in public, so you don't want to hide them because they come, for example, from an open source model, then also you see a lot of improvement in speed because the operations are not that hard. And that being said, the kind of front line of research on this is on how to accelerate the evaluation of the nonlinearities of the activation functions. And I was just presenting before just an example of that, which is the work that we did in collaboration with Meta and University of California, is porting some techniques from wavelets, from discrete signal processing, to actually compress the lookup tables that you use for that purpose. And we've seen also very interesting improvements, like tenfold improvements.
I think to dovetail with that, on the trusted execution environments, because we primarily focus on training as opposed to inference, we find that the performance degradation is higher than 10%. It's closer to like 40%. And that's typically just due to the amount of additional operations you have to do and kind of read writes into the memory on the back propagation of training. That forces us to look outside of TEs and think, okay, well, how else do we solve this? And also because TEs and the kind of enclave technology has the security concerns and it's not fully kind of, in the market, it's only a small number of GPUs that have it, like the Blackwell and Hopper architecture. We basically think, how can you get, maximally all the devices impossible? So you have to look for new verification strategies. For us, that often means coming up against a reproducibility problem. So when we do one of our verification strategies, which is a kind of deterministic strategy where you do a pinpoint protocol. Basically, there's a trainer, there's a verifier. The trainer executes the graph. The verifier takes a section of the graph. They make Merkle trees, and then they play a game to pinpoint operations in the Merkle trees, which are conflicting. You require bitwise exact reproducibility between those two devices. And in order to get that bitwise exact reproducibility, if they're different models, is actually a pretty non-trivial challenge. You kind of get non-determinism everywhere from the model itself to the framework level to the GPU kernels and how they're written, all the way down to the actual physical memory plates on the GPU, which can get hit by kind of cosmic rays. So the whole kind of stack is kind of fragile. We spend a lot of time working on solving all those non-determinism issues, from having a custom compiler that we build to a custom runtime, all the way through just a monkey pack showing GPU kernels. So I'd say for us, when we think about verification and its use in kind of accessing all the supply of GPUs and relevant compute devices, the big problem is reproducibility.
I see. I'll ask a question about the privacy side, but first a question on the training and the data side. It seems like one of the theses here is that it seems plausible that these decentralized methods could be competitive with some of the more centralized ones. I'm curious, how you see that evolving, and if you have any predictions for if some of these decentralized methods could overtake some of the centralized approaches by the big AI labs right now.
Yeah, I think one thing that actually changed my mind on decentralized training, which I was previously very skeptical of, is looking at literally just the sort of ballpark estimates of how much compute power did all Ethereum miners in the proof of work days have versus how much compute power was used to train GPT-4. And it's 50 times as much, right? So even if you take a 10x hit in performance, you can just access so much more compute in a crypto network. And I think that's really powerful. In terms of one of the research areas I think is very interesting, it's actually this model merging type technique where you can asynchronously train models. So it's kind of more like an open source pull request of hey, I train a little piece of a model and then somebody else trains a little piece of the model. You can all stack them on top of each other. Some people call them Franken-merges because you're Frankensteining pieces of the model together. But I think that's another interesting kind of area that's happening within AI training.
I was going to say the second point, so the Franken-merging point. I think there's also the idea that you can kind of just have separate models on a network and chain them together. They make more sense in a decentralized setting than in a centralized setting because they're just naturally more open and accessible. So there's kind of papers where you look at dynamic routing for different models for a given request, as opposed to just routing through one, say, centralized mixture of experts model. So yeah, I would agree strongly with the second point.
How much do you see those different ways of training things as being things that require new research versus the research is there, we just have to start applying it?
So model merging specifically is really interesting because it's kind of more used in the open source like hobbyist community than I feel like the pure AI community. So there's a lot of like image generation community, some of it around anime, some of it around honestly like not safe for work content, where a lot of this has proliferated and like allowed for great research to happen. So yeah, in that case, it's actually more happening in the like hacker hobbyist community, but I'd be curious to hear from you too.
Yeah, I think there's a long tail of research on it. So I think like batch train merge or batch train mix as well were two kind of approaches using, for training mixture of experts models, for example, which are very well suited to the decentralized and highly parallelized settings we're talking about, where asynchronicity is a feature. I think in terms of the additional research required to make it work, I think when you scale it up to a very, very large size, you usually have, and you compare it back to say like large transformer architectures that are in centralized companies like GPT-4, it's kind of taken for granted that they have mixture of experts layers and stuff like nested inside them at various points in the between the feed forward layers. I think how you architect an end-to-end pass through a decentralized network in a way which kind of acknowledges the dynamic like latency between all the different pieces is a challenge. So I think just from like a pure like production engineering perspective, if people care about inference speed, even if you have one of these kind of chained models, you need to kind of have some like meta optimizer, which is looking for the fastest path through them all at the same time. And I've not seen research which combines the two in a way which is satisfactory.
I see. Question on the privacy side also, like, what do you think has to happen, or what is next to like get? Do you see a path, I guess, to having models that can be evaluated in a private way for like larger models and like competitive with like the GPT-4s and stuff of today?
I think that eventually we may get there. I mean, we are now at GPT-2 level, but again, like 6 years ago, we were at level of 1,000 parameters. So there's been a lot of progress that has been made in the last 6 years, and there's no reason to believe why that wouldn't be continuing along the same lines. I think there's going to be a lot of work being done in the compression of models that is going to benefit privacy-preserving technologies. I'm talking about not just making smaller models like Llama is doing that more or less behave or perform like larger models, but also about quantizing the weights, like working with binary weights or sometimes with 3 values. The interesting thing there is that when the weights, again, are public, it allows you to do all the operations modulo 2 or it's more in a small ring, which are way faster to perform, and actually you get rid of the multiplications, which is the main bottleneck, and you can work, for example, with additions model or 2. That's like an acceleration that has a profound impact on multi-party computation in particular. And so the more we see of those models that are trained, because the problem is that you need to train those models already with those quantizations, the more we see of those models trained that have like performance and sizes that are equivalent to the larger ones, I think that's the way that we can really achieve the same type of behavior and accuracy while working with really smaller models and smaller techniques. Yeah.
There was some research out this week about the limits of quantization being reached in terms of compressing into the kind of smaller bit widths. I don't know if I can't remember who did it, but did you read that, or are you aware of it? This idea that,
Yeah, there is a limit to that, but you can complement that with other techniques, like the one we came up with, which it's an alternative to quantization that does not incur into higher approximation errors. So it allows you to compress the operations, the kind of the lookup tables that you need for the operations, in a way that doesn't increase the accuracy problems. And so both combined can be, I think, very interesting, a very interesting avenue for future research.
Interesting. And maybe a hard question, but I'm curious, like if we look at all the centralized AI systems right now, a lot of them have filters, restrictions placed on them that limit how they can be used, sometimes in ways people might agree with, like not having instructions to make like a bomb or like a bioweapon, but sometimes in ways that feel a little like overly restrictive. I'm curious, like how you think that can or should work or will work in like this decentralized AI setting?
I think it should be absolutely uncensored. I think, you know, from an artificial neuron perspective, it's an extension of your own biological neurons. No one should control them. Liberty starts with you. You know, it's not necessarily a right, but it's not something that someone can or should be able to take away from you. And I think that extends to software, particularly open source software. So, yeah, I think it's kind of non-negotiable.
I think I'm a little bit more cautious on that end because of, you know, there's potentially harmful prompts like advocating for suicide, terrorism, and so on. But I do believe that it shouldn't be controlled. It should be monitored or kind of controlled by a DAO in a decentralized way, so that, you know, the community is the one deciding what is good, what is bad, what is admissible, what is not, and so that no central entity can ever censor, you know, what goes into an LLM that is running under decentralized infrastructure, because that would be like a no-go, like a red line for me.
Yeah, I also think it's much of a problem. We should be in a situation where we can actually, you know, have like LLMs that are not restricted. The problem is that even on the open source, you know, approach, you know, the big model and sort of like the reference today is the Llama 3.1, and Llama 3 has been created by Facebook, actually, and by Meta. And if you actually, like, there was an article also that got released like a week ago that was saying that Llama 3.1 is not purely open source, you know, depending on the definition that you're giving to it. But in a way, that's the case. And the thing is, we're depending on those huge companies actually to have the models that are, you know, like have a lot of parameters and that are, you know, trained on like trillions of tokens, because they're the ones who actually can spend a lot of money, you know, because they don't actually, you know, get to, it's not a problem for them to lose the money, you know, in a way. So that is very much of a problem, because even those open source models are not very much so. And so I think we should be heading into a direction where we need to embrace pure open source models where we have, you know, much more openness in terms of what we can do with it.
Yeah, I think the question of censorship is very closely related to the question of truth, right? Just like, what is true and what should the AI model say when you ask it, which is a very hard like human coordination problem that I don't think we've ever solved. So I think there are decentralized kind of community-oriented approaches, but we should also be pretty realistic about like, hey, we didn't solve it fully for social media on like what is truth. And so kind of having a reasonable bar for ourselves. Makes
sense, yeah. I guess I wonder, like, okay, if we look like, you know, 2, 3, 4 years out from now, what do you imagine this ecosystem looking like of like the centralized companies, like this new wave of decentralized approaches to training and inference? How do you imagine that ecosystem looking?
I think there'll be a parallel economy and like a kind of parallel civilization, and it will be completely electronic. Machines will transact with each other as much as they do with humans. And I think for it to be truly kind of sovereign, the machines need the ability to do kind of three things. Firstly, you need cryptographic property rights, which they won't get in centralized settings. Secondly, we need the ability to learn. So decentralized kind of compute protocols and data are a requirement there. And thirdly, and crucially, we need the ability to update their own objective function so that they're truly autonomous. And I think that everything that's happening here helps enable that in a few years.
Do you imagine then like a world where like these AI agents can like kind of pay on chain to like upgrade themselves or something like that?
Yeah, I think that's kind of taken as read just now by everyone. I think that's the base case. I think the most interesting kind of question is the extent to which, as a society, we're comfortable just letting that exist by itself. So, for example, every kind of relationship humans have had with tools throughout history have been very much like it's a tool for a human. But this is a weird kind of evolutionary fork where maybe there's this parallel thing which is existing and creating value and has its own culture that we don't even reason about. And what they use money for might be distinct for what we use it for.
I see a world of personalized AI being kind of our proxy, intermediating in every interaction we have with others, and in continuous conversation with ourselves, which is very exciting, but at the same time a little bit concerning, because that AI will have a lot of access and potential power over us and the ability to manipulate us. And so that needs to be, I think, addressed by privacy, so that there's no company, and by decentralization, so that there's no company sitting behind tapping, and utilizing all that power that this agent will have over us. And I think agents will, this type of agents will permeate every relationship, even, not only interpersonal, but also between companies. Like the way for companies to interact with one another will be through agents that instead of having a meeting for a negotiation between party A and party B, maybe there will be a pre-negotiation taking place between their agents, their AI representatives, to see the potential for success or not. And again, privacy is really important in that sense, so that you can negotiate by even using some sensitive information from both companies, but actually without exchanging, without sharing that information. You can know the outcome, if it's going to be good or bad, even before you share that information, even before you sign the actual contract, that enables you to share that information. So yeah, it's an agentic future, but I think very importantly powered by decentralization and AI and privacy.
Yeah, I completely agree on the decentralization aspect of this. I think we're going to be seeing a world of like open ecosystem and economy for AI, and obviously the risk, as you just mentioned, of having one or a couple of entities, especially if they're malicious, to basically reach AGI will be extremely problematic around the world, and will give more power to centralized entity, and not basically giving the power to the users all around the world and the people who are contributing to it. So I highly believe into like a very open ecosystem where people actually, there's also this question that's being asked of like, will proprietary models still, be more performance in the future than like open source, for instance? And I strongly believe in the fact that open source will surpass it because of the power of the knowledge and the power of all of the amazing developers that can actually share their knowledge in order to surpass it. So yeah, that's why I see a future where it's going to be like really, really open on that. And the Web3 side of things can be very interesting because AI is very limited in terms of its economy. And I think that Web3 can actually, with crypto incentives, can actually bring a lot, to this black box.
So purely from an AI perspective, I think the next 4 years are going to be just like insane from a progress perspective, right? Of like, we have basically invented almost like a new kind of like electricity or water, which is just like on-demand intelligence, right? And then you're going to be seeing this whole new economy form on top of that new kind of just readily available intelligence. I think that data almost becomes like a new currency in this AI native world, right? Where like really what the AI wants is like data and information to learn from. And so I think we're going to see a lot of that kind of like shaping and new reorganization of like commodities around AI agents. More like tactically, I also see like I want 10 AI Annas who can go like autonomously do work on my behalf and can like collaborate with others. And I think we'll start to see more and more of that happen as well.
Also, really briefly, I wanted to add one other point, which is like the way I see things in terms of reaching AGI in a way is set up in like 5 different steps. So like first step is basically like, the chatbots, which we've all seen and all experienced, to a larger scale. Step number 2 is reasoning. We're getting there. We started seeing, like the first efforts, even though it's coming from OpenAI, but like, with O1. Step number 3 is basically like fully fledged AI agents. And what excites me a lot, and I think we're going to be reaching step 4 in the next 3-4 years, is actually innovators. Like having models and agents that are so smart that they can actually cure things that humans haven't been able to do in the past. Like basically cure cancer or cure, like diseases and sort of like innovate in research where it becomes more intelligent than humans. And I think we're going to reach this step in the next 4 years. And then the last one being, so like fully autonomous agent society being like the last step of it, which I believe is going to take a little bit more time.
really interesting. Like, I guess I wonder, like, if we're going to reach this world where, like, there's all these agents and they have this level of autonomy and this decentralized AI stuff is going to have a role in that, how do you think about, like, ways to try to guide this in, like, a positive direction, if we can or if we should? How do you think about that?
I struggle a lot with the idea of the tyranny of the majority. So I really strongly dislike the idea of there being a group of people in control of or stewarding it. Even if there's consensus from like 70% of people in society that, you know, something should be this way, I think it should still be credibly neutral. In the same way that, you know, at least in the West, our view on the internet is that it should be completely open and there shouldn't be any kind of, you know, limits on it. Whereas in other cultures and sort of countries, the internet itself is censored. I just fundamentally short circuit at that level, even before I mean, I can obviously see like issues with runaway intelligence and stuff like that, but yeah, I struggle with it philosophically.
Yeah, I think that right now we're in a very bad situation in the sense that a handful of companies are just owning the whole, you know, product value, the whole value line of training and collection of data and inference. To open that black box, one of the ways to do that, I think, is privacy. Because if you are able to protect the key assets that are transferred between data collection, which is the data itself, training, which are the model weights, and then even on top of that, provide privacy to the users, I think that's the way to enable new companies to come into the space, create marketplaces in each one of those, so a marketplace for data collection, a marketplace for training, a marketplace for inference. And that is the way, I think, the path towards decentralization.
I think part of it, too, just comes from having like the right builders in the space. I think a lot of crypto people have very strong principles around like self-sovereignty and freedom that I think the open source AI community can benefit from a lot. And so I think part of it, too, is just like, how do we bring more of those principles and those builders into the space?
I think that's all the time we have, so thank you, everyone, and thank you all for listening.